Hey guys, I hope you're all having a fun time with our Summer Innovation Challenge Box program. My name is Kobe and I work at NSWC Dahlgren Division. At NSWC-DD, we pride ourselves on technical excellence as we are a product-focused and mission-driven organization. As an aerospace engineer, what we typically do is develop systems, such as this one that I have with me today, and we try to make them perform as best they can. We do that by either changing the way they look, changing specific features of them, or just simply testing it out in the field. The systems we develop here at Dahlgren are meant to help keep our sailors safe and defend our country. I specifically work with computer simulations of projectile flight. This process is called computational fluid dynamics, or CFD for short. Computational means it's computer-based. Fluid is referring to a gas, such as the air around us, and dynamics is just the motion of a body under forces. If you know the game Angry Birds, it's a good example of what these simulations actually look like. But what exactly is a projectile, and what are its dynamics? A projectile is any object that is propelled through the air. This means any object that is thrown, kicked, launched, or fired could be considered a projectile. I have some examples here of what those projectiles could look like. These projectiles experience four main forces: thrust, drag, lift, and gravity. Thrust and lift are what keep a projectile in the air, while drag slows it down, and gravity causes it to fall. To maximize the range of a projectile, you should try to increase the thrust or lift of it. Unfortunately, we can't change gravity, but we can design a flight body to reduce drag. Typically, at high speeds, a sleeker, skinnier design is more aerodynamic. For your challenge today, you're going to be tasked with designing a launcher for different projectiles. Feel free to design your own projectile with whatever you can find around the house, such as a ping pong ball, a paper ball, or tin foil, or even a cotton ball. Anything that you find that you can fit inside of the toilet paper tube that we provide. Additionally, you will also be provided a target to aim at. But don't let that stop you from making your own target at different distances. Keep in mind that some projectiles are more aerodynamic than others, so figure out which one goes the furthest. What we're going to need today is 2 different toilet paper rolls, and the smaller one will need to have some sort of hole punched all the way through. And then you're going to need a pencil to actually stabilize it, and 2 rubber bands for either side. For step 1, what we're going to do is put the pencil through the smaller toilet paper tube. Next thing, we're going to take the larger toilet paper roll and make some small cuts at the top of it. Then on the opposite side, make the same 2 cuts. Then you're going to put your rubber bands inside of those 2 small incisions that you made. So that way it's secured. Once you have both rubber bands securely around the toilet paper tube, it should look something like this. Next, feed the smaller tube into the larger tube and stretch the rubber bands around the pencil that you stuck in the smaller tube. And there you go. After you've completed your launcher, it's time to actually aim at something. We have this paper target here that you'll be aiming for. For a science experiment, we have variables and constants. A variable is something that you change, versus a constant, which is something that you keep the same. For today's experiment, the launcher will be our constant, and the projectile will be our variable. Make sure not to make your projectile too light or too heavy, otherwise it might be difficult to launch it. I missed, but I'm sure you'll do better. So, good luck, and have a great summer.